We're going to look at how we can manage fragments, get a deeper understanding of fragment transactions, and talk a bit about how fragments manage state, as well as how fragments themselves are managed as state. So we're going to talk about the fragment backstack. We're going to look at how information can be persisted and some of the considerations that you will need to keep in mind when you are using fragments inside of a host. First, let's talk about the backstack. So, a backstack is a structure maintained by the fragment manager within each activity that allows you to record or keep track of fragment transactions. In a way, the backstack maintained within an activity is similar to the task backstack that keeps track of activities in a task, but they are different. Essentially, you can think of it as a hierarchy of backstacks. A task maintains a series of activities, and then each activity, if it is using fragments, will have its own internal backstack that keeps track of the fragment transactions. Now, it's important to understand that what we are keeping track of is the transaction, not the fragments or the operations per se. And what do I mean by that? The comparison between the activity backstack, that is the backstack that keeps track of activities in a task, and the fragment transaction backstack sort of breaks apart when you think about what you find in the backstack and what can be done with the things there. With activities, an activity in the backstack is in the foreground, potentially in the background, but once it's removed from the backstack, the activity is gone. With fragment transactions, however, and when we're using the backstack within an activity to keep track of fragment transactions, a fragment could be removed or replaced in a fragment transaction. So one of the operations could be replace or remove. And in that scenario, you could imagine that the fragment is not a part of the host activity anymore. But in that sense, the fragment hasn't gone away. And you can, in fact, reverse the transaction if it's on the backstack. And that will bring a previously removed fragment back. So you are essentially undoing the transaction, whatever the transaction described, or whatever operation the transaction described, including the removal or replacing of a fragment. That can be undone when you reverse a transaction. That transaction can be reversed either by the user when they hit the back button or perform a back gesture, or we can do it programmatically with a call to pop backstack on the fragment manager. Now, one other thing to keep in mind as we're using the backstack is that depending on whether or not a transaction is placed on the backstack, the lifecycle of the fragment, or how we transition from one state to another, will be impacted. So, for example, if we perform a remove operation within a fragment transaction, and that transaction is placed on the backstack, the fragment will be stopped when that transaction is executed. That is, again, because we could potentially reverse that transaction. Therefore, it's important that the fragment itself remain in memory. Conversely, if the transaction is not placed on the backstack and is not reversible, then that remove operation will result in the fragment being destroyed. So let's look at an application to see fragment transactions in action and get a deeper understanding of sort of how they work. So here we see an application that is using an image fragment to display images. So this image fragment accepts a collection of images and then displays those images one at a time, where an image is replaced whenever the user clicks on the contained image view, or if it has its change image function invoked by the external host or parent. In our activity, we see that we have two instances of a fragment. The first is given a collection of drawable resource IDs for desserts, cakes, and the second instance of our fragment is given a collection of drawable resource IDs for deserts or large swaths of arid land. Both of these fragments are then attached to our host via a single transaction. So we see the add operation being performed, and we're placed in two containers. So these are the IDs for two fragment container views. And we also have a button on our activity that allows us to call change image on both fragments, resulting in random image changes across both fragments. So that's what we currently have. So this transaction to add the fragment instances are performed automatically because this is done in our onCreate. A fragment transaction can add a fragment, but it can also perform other operations. For example, it can remove a fragment, it could replace a fragment, it could add, attach, detach, etc. So there are a series of operations that we can perform. Now, when a fragment transaction is executed, as we see here, if I perform the back gesture on my application, you'll see that the activity is destroyed, as you would expect in any other similar application that was not using fragments. Essentially, hitting back just kills the current activity. However, if I were to say that this operation should be added to the backstack, I'm asked to provide a tag, essentially a way that I can look up this transaction later on. If I'm not intending to look it up, I can just use null here. If I perform this operation, what I'm saying is I want to record this transaction to the backstack in a way that allows it to be reversible. If you're going to perform operations on the backstack, or if you're going to record a transaction to the backstack, you should, as a matter of course, call set recording allowed, reordering rather, to true. And this essentially allows quick changes of fragments without having to go through all of the state transition. So if you're adding a fragment and then immediately replacing it, for example, by calling set reordering allowed, it will be a little more efficient because it won't have to perform all of the state transitions for the adding of the fragment just to have it then immediately be replaced. So this is not set to true by default, but you should in fact do it, especially if you're just operating on more recent versions of Android. So we add set reordering allowed as a matter of course, and then we call add to backstack to say that this transaction can be reversed. The result of this change is when I now hit the back or perform the back gesture on my activity, instead of the activity being destroyed as it was previously, what we will now see is that the fragment operation is reversed. My activity is still running, and only if I hit back again is the activity then destroyed when there are no other transactions to be reversed. So adding to Backstack, again, performs that or records the transaction, and it allows me to reverse the transaction. And that is any operation that was performed is going to be reversed. Now, we can add multiple operations to a Backstack or leave an operation off. For example, let us say that the first operation we perform is not added to the Backstack. And what I'm going to do is I'm going to change the functionality of my button, where initially I would call change image the exposed function on the fragment. What I'm going to do now instead is when I hit change, I'm just going to perform another operation, placing new fragment instances on the within the same containers. So I am going to add another fragment and our first was dessert images, and then a second and now I am going to add to Backstack. No. So I don't need this call here because I'm not adding this operation to the Backstack. So here you can see what's happening. When my application first launches, we create two instances of our image fragment, and we place it, we attach it to the fragment, or we add them to the activity rather. And then subsequently, any click of the change button will actually add new instances to the same containers, fragment container 1 and image fragment container 2 respectively. Now, this is of course allowed in Android. You can add multiple fragments on top of each other in the same container. So hitting change image gives me this operation. Now, you may notice, at least in my bottom container, that you can essentially see the overlap. Apparently, these images are not the same, are not sized equally. So you can see sort of images being placed on top of other images. That is, of course, because we have the fragments being placed on top of other fragments. And because all of these operations that were performed via clicking the button were placed on the Backstack, it means they can be reversed. So if you were keeping track, you can actually see we're going back, and this may be the last one. So when I hit back, we're now at where we got all the way back to this operation or to this transaction. And when we hit back, because this was not on the Backstack, the activity was destroyed. So let's talk briefly about fragment state. Basically, when we are working with fragments, there are two things that we want to consider. We want to consider how a fragment manages its own state information. If we think of a fragment as a modular piece of an activity, and we think of a fragment as being able to do a lot of the things that an activity can do, then we want to be being aware of the fact that an activity can manage its internal state through things like configuration changes that require state management. A fragment has the same considerations. So that's the first thing. We want to think about how a fragment manages its state information. The second consideration when it comes to fragments is that a fragment itself, being information that is contained within a host, is state. So we also want to understand some of the implications of a fragment's design as it relates to it being data inside of a larger context, such as an activity. So first, when it comes to managing a fragment's state, the good thing is we have a model that we can follow, because it turns out that a fragment manages its state in a fashion similar to the way an activity manages its state. So a fragment has an onsave instance state function where you can implement your logic to save any configuration data or any active data that the fragment needs or needs to know if the fragment is destroyed and recreated by the framework for any reason, such as a configuration change or being attached or detached from its host. Unlike an activity, however, our fragment has multiple places where that data can be returned. So that data can be returned via onCreate in a fashion similar to an activity, but it can also be returned in onCreate view and in onActivity created. So the need to manage your state across these different functions is a result of the fact that a fragment has a more complex lifecycle than an activity, and multiple things can impact when a fragment is being created or recreated, such as being removed or replaced in an activity, the activity being destroyed, but the fragment being retained, the fragment being destroyed and recreated while the activity is retained. So essentially, the easiest thing to do here is simply reference a documentation to have a deeper understanding of if and when you need to manage your state across these different functions. One of the more interesting, or if insofar as novel considerations when it comes to state with fragments, is how do you deal with fragments as state? That is, when a fragment is in an activity, or conversely within another fragment, or similarly within another fragment, how do you make sure that the fragment is being managed properly? Well, the main consideration as it relates to managing a fragment within an activity is that we must always be aware that by default, the fragment manager will retain any activity that is currently attached, or to put it more broadly, any activity or any fragment that has taken part in a fragment transaction that has been recorded, or operations that were in the backstack. Those data, those operations, those transactions are going to be remembered by the fragment manager, even if the activity is recreated. That is, it's destroyed and created again through a configuration change, for example. This is the default behavior. A fragment that is created and attached to an activity will remain there, even if the activity is destroyed and recreated. If you would like to change this behavior, you can call setRetainInstance with a false value, and this will change that behavior. Now, what is the impact of the behavior that we're describing here? Well, let's do a slight modification to our application as we're running it here to sort of see what we're talking about. So we have an operation here where we add two fragments to the containers in our activities layout. And we see them here. Right now, I am not adding that transaction to the backstack. So there is a particular issue that we have here, but we're not really seeing it. Well, firstly, because we have not done anything that would trigger the problem, but also because it's not on the backstack, it might actually not even be clear to us. But let me show you what the problem is. And again, it has to do with the fact that this operation is going to be remembered. So if I do a rotation of my device, I get two new images being displayed. And the reason I'm getting two new images being displayed is because when I do that device rotation, my activity goes through a recreation process and the uncreate is invoked a second time. That means I go through this and all of this logic where two fragment instances are created and they're added. Now, that may not seem like anything has really happened here, but the reason it doesn't look like anything is because I am not adding these operations to the backstack. So something that is happening here is not apparent to us, which is the original fragments that were attached are still here. We just don't have access to them. Now that I do a rotation again, you can actually see it thanks to the fact that these images are differently sized. So you'll notice that I'm seeing another fragment below the fragment that's on top. Now we can actually fix this problem, or not fix the problem, but make it more obvious by adding this operation to the backstack. And again, I have to set reordering allowed to be true, just for compatibility reasons. And now I can actually see the problem when I try to kill the activity. So I run my application, the activity loads, and I get two images, and I'm going to do a rotation here. And another rotation. And I'll see that, again, it's visible at the bottom, thankfully. So we are aware of the problem, but it'll become obvious when I start to hit back that, oh, it turns out that I have multiple instances of each of these fragments. Do another rotation. And another rotation. And again, multiple instances. Hit back, hit back. So there are a couple of ways that we can address this. One way is the correct way. The other way is the incorrect way. Let's look at the incorrect way first. One way that we could almost skip this problem is that we could, instead of having an add operation, we could use a replace operation. And if we had replace operations here instead of add, the reality is we may not have even noticed the problem. And the reason we wouldn't notice the problem is that instead of having a fragment simply being placed on top of another one, what will instead happen is the fragment currently in the container will be swapped out and another instance of the fragment is going to be put in its place. So you will only ever see one instance of the fragment. Now, it so happens that we can figure that something is a little off here because, of course, we're getting a different image every time. That is, of course, because my fragment is displaying random images every time it loads. So we might be able to determine that, okay, maybe something is a little off and address the logic. But we're going to talk about that in more detail in a minute. For now, what we want to be mindful of is the fact that the replace is getting rid of a fragment and putting a new one there. Now, why is this not the best approach? Well, it's not the best approach because we are essentially wasting an optimization by getting rid of something, assuming that we wanted to actually have the fragment when we do a rotation. We are, at the very least, discarding a perfectly good fragment that was already loaded into memory just to create another fragment and put in its place. Now, it may not seem like much here because these fragments are not very complex, but you could imagine that a fragment implementation would take some amount of time or resources or clock cycles to compose itself, and then to simply discard it to create another identical fragment is simply wasteful, and that will essentially reduce the responsiveness of your application. So what we would like to do is retain a fragment if it's already there. Why discard a fragment just to replace it with the identical fragment? So this add, using replace instead of add is sort of a cop-out. It doesn't actually fix your problem, it just works around it. The actual fix to this problem has to do more with figuring or realizing that there is already a fragment in the location and opting to not add a new fragment if one is already there. So to determine whether or not a fragment has already been attached to a container, we can do this in a couple of ways. The first thing we can do is we can use the fragment manager, and we can check for a fragment by calling find fragment by ID, and by passing in the ID of, say, one of the containers or both of the containers, depending on your logic. And you can basically do a check to see if this particular fragment is not null, or you can go further to check whether or not it is of a certain instance. So I can take this fragment and check, hey, is this particular fragment, is it a is it an image fragment? If that is true, or if it's not true, then you can decide whether or not you will perform this operation. So checking for the type of fragment is useful if you have different fragment instances that may or may not be in a single container. Being able to verify what fragment is currently attached can be useful. So you could spell it out like this, or you can do a much more straightforward version and simply rely on our saved instance state that is passed into our activity. Essentially, saved instance state will be not null if there is a fragment attached to a container in our activity. With that knowledge, we can do something as simple as saying check if saved instance state is equal to null. If it is, we perform this operation. So the logic is the first time this activity loads, save instance state will be null. Therefore, we can perform this operation. Once this is performed, any subsequent loading of our activity, saved instance state will be not null. Therefore, this will be skipped. So we will not add another instance of the fragments. So we can test this. And here we see our fragments are added. And if I do a rotation, and for simplicity, we'll do another, I see that when I hit the back button, the fragments are removed. We get empty containers. That is because after this first operation was performed, no subsequent operations were performed. No subsequent transaction was executed because save instance state would be not null because we performed an operation. The activity is now keeping track of this fragment as its state. Therefore, save instance state is not null because that is saved for us automatically. We didn't have to manipulate save instance state ourselves. That information is retained automatically. So that's a kind of a straightforward way of doing it. Obviously, you get more control if you spell out your conditions to verify that a specific container does or does not contain a certain fragment or a certain fragment type. Now, what you might notice is that even with my application providing this safeguard, when I do a rotation, you'll notice that the image that is being displayed will in fact change. Now, the reason this change occurs has to do with the fragment saving its own state information. Essentially, every time we do a rotation, our fragment goes through a series of lifecycle changes. Invariably, the view of the fragment is destroyed and then recreated. What we need to do then here is similar to the way we manage state manually in our activities. We need to manage the state of the fragment to make sure that when a particular image is being displayed, the fragment remembers the currently displayed image and retains it. So here's what that looks like. First, what we're going to want to do is keep track of some value. In this case, the value or the index, perhaps as just as straightforward as more straightforward, of the image that is currently being displayed. So we're going to have some key, which should be private. And we're then going to override our fragments on save instance state. Once here, in our out state, what we would like to do is put an integer with this key, and the value we want to store is either the index or the specific resource ID. In this scenario, I don't think it really should matter which. But let's, for now, simply because we know the collection doesn't change once it's provided, let's just save the index. That seems a little more straightforward. So to save the index, what we will need to do is have another property. So in this case, it will be a variable. We need to be able to change it, and we'll call this current index. And we can initialize this to 0. Really doesn't matter. And then what we will need to do here is in our change image function, we need our random. It turns out because we were using the random function call, which returns a random value and not the index, then this really it doesn't make sense to keep track of the index because we don't have a ready way to get the index. I'd have to change the logic. So we'll just call this current image ID. And it's all the same to us. And we'll have current image ID be this value. In fact, let's call this a late init rather than initializing it to 0. We'll do a late init. No, I can't do a late init for a primitive type. So we should know that. So we can make it nullable. But let's the reason I didn't want to have it as a 0 is, I mean, we can make sure that our logic doesn't allow it, but because we're storing the image ID and 0 is not a valid image ID, I wouldn't want to run into any potential issues with trying to use an image ID of 0. But what we'll write around it. We'll make sure that our logic is solid enough that we never use the value of 0, because we know there are no image IDs of 0. So what we'll do here is store the current image ID. So the logic is current image ID there. So the logic is every time the activity, every time we call change image, we store the value of we store the value that we're currently using, we display it, and then whenever onSave instance state is called, we store that in outstate. Now, all we need to do then is make sure that whenever our view is recreated, we display in our image view the current image ID. What we can do is verify this saved instance state value to see whether or not we have a current image ID. So what we'll do here is basically specify that if save instance state is, because it may actually be null. If it's not null, then we want to extract the int value. So we want to get int, and our key will be current image key. That value we will save to current image ID. And then we want to verify. In fact, we could put a default value in case we don't find anything. And then we want to verify if current image ID is equal to 0 or not equal to 0, then call change image, which is going to generate a random image. Otherwise, what we would like to do here is set the image view to be a specific, to display a specific image, specifically the one stored in current image ID. So we could modify our change image function to either overload it so that we have one that takes an argument as well as having one that does not. So maybe we, instead of manipulating the image view directly in onViewCreated, where we have not done that for anything else. So let's have another function, change image. This one will take an integer. And then we will set the image view to be image ID. And because I now have this function, what I will essentially do is call change image here. So I'm reusing this function so now we have only one function that can actually change the image ID. So if you call change image without an argument, it generates an ID and then calls the change image function that accepts an argument and does the update there. I wouldn't want to have my image view being modified in two different functions. That is going to cause problems later on if I change some germane aspect of how my application works. So you always want to keep things done in a single place. And then here we now call, if it's not equal to 0, we call change image with the current image ID. All right. And let's see. So I'm just trying to see if I could simplify this by putting this here, but I wouldn't, since if this is null, it would skip executing the code. So the proper way to do this is to initialize here and then go through. So I'm only doing this in onView created. Let's see if we get the result that we want, or if I need to invoke this in other places, but I suspect this should be sufficient. And it is not giving us what we would like. So let's see if current image ID is, oh, my logic is flawed. If it's equal to 0, call change image. Otherwise, call change image with an image ID. So I had it in reverse. So here we have, so it would have been good to put the names here. So we have this cake. Looks like a pineapple upside down cake. Let's call it that, with the swirl and the cherry. And I don't know my deserts either, but keep a mental image. And then we'll do, in fact, I'm just going to turn on auto rotate so I don't have to keep doing this. And auto rotate is not available. Oh, okay. We had way more options show up right afterwards. All right, so these are my cakes, and I'll do a rotate. Same cake, same dessert, same dessert, and same dessert. So I'm keeping track of my modified state inside of each fragment. That is how I'm making sure that I'm always showing the same image rather than generating a new random image each time. And I'm also considering the default behavior of a fragment in an activity, which is if a fragment is already attached, I do not want to create another instance because I know that by default, a fragment retains is retained rather in a container to which it was previously attached if that container is recreated.